in this question, we need to figure out the total power output of the turbine, and this is the turbine, and it got an efficiency of 75%, right? So by efficiency, we mean that it is capable enough to convert 75% of the input energy to the output energy. So if you are putting in 100 joules, it will convert 75 joules, or it will give 75 joules at the output, right? So this is 75% efficient system, right? But now the problem is, first we need to figure out how much energy we are putting into the turbine, and then by taking the 75% of that total energy that we are putting into the system, we can actually calculate the power output. Okay. So first step is to calculate the total energy input, all right, or total power input we are giving to the system. So the power that we are giving to the system is, so see, this is the lake containing a lot of water, and water flows down, and there's a change in gravitational potential energy, right? Because water flows down due to the change in gravitational potential, which is converted into the kinetic energy, right? So initially, the water over here in the lake is having some potential energy, and that energy is getting converted to kinetic energy, right? So first, we need to actually figure out the change in potential energy, and that change in energy divided by in what time that change took place, that will give us the total power input, right? And the clue is we are only going to do the working for 1 minute, because for 1 minute we know how much water is flowing. Okay, so the time is given to us, which is 1 minute. So in 1 minute there are 60 seconds, so we can say that the power input is equals to the time is 1 minute, so we can say 60 seconds. And in 1 minute, 2400 kg of water is flowing down to the turbine, right? So we can say that 2400 kg of water is actually getting low in the gravitational potential energy, right? So how much energy is being converted? The change in gravitational potential energy, the formula for gravitational potential energy is mass times gravity times height, right? So how much is the mass in 1 minute? 2400 kg, right? And this is the mass. Now again, this experiment is being done on Earth, so we are going to keep the gravity as 9.81. And similarly, lastly, we have the mgh. So h is representing the height, which is the height by which the water is flowing, and the height is 90 meters. So we'll keep height as 90 meters, and this will give us the total power input to the turbine. And this comes out to be 2400 multiplied by 9.81 multiplied by 90 divided by 60 seconds, and we get the total power input as 35,306. Okay, so power input is equals to 35,316 watt, right? Remember, the unit of the power is watt. Let's move it up. Now we know the total power input, right? And we can easily compute the total power output because we know the efficiency of the system, right? So if you are giving 100 watt as an input, you are going to get 75 as an output. So if you are giving 35,316 as an input, then you are going to get 75%, which is 26,487. So I can say that option A is the actual answer, which is closest to the right total power output.